Good evening to all the participants present today. First of all, before starting conversation, uh, you can't hear me? Now my voice is okay?
Yes, sir. Okay.
Yes, sir. Okay.
Maybe that's due to internet issues. Sometimes voice may go low. Please pardon me. Please make me aware so that I can take corrective action. Now, uh, before starting today's lecture or presentation or demonstration, what you may say, uh, as customary for me, I start with a prayer before proceeding to my session. So let me start with a prayer. You can also do along with me. Om, Om, Om. Lead us from unreality to reality. Lead us from darkness unto light. Lead us from death to immortality. Om, Om, Om. So, the course, as far I remember, is a hands-on program on research methodology. So, please let me know that whether you have got SPSS with you, can you do the hands-on session along with me? Because on the basis of your answer, I will
Yes,
approach
sir.
my session.
Yes, sir.
Yes, sir. Yes, sir.
So I will request you all that if you can check your email IDs, respective email IDs, Dada has sent you two data sets. One Barger data set, the other is YouTube survey data set. Both are original real data sets. So I will try to make sure that I use both the data sets in demonstrating the classification or rather cluster analysis technique that I've been assigned to teach today. Now, I want to correct the other that I am not the expert of these SPSS. I am also learning because learning never ends. And I don't think I have become an expert. I am a student of research. I try to learn new things and try to share with all my colleagues and participants. So I'm not an expert, but you can tell me that I am a learner. On that note, uh, we will start today's session, which is on classification or cluster analysis. Be ready with both the data sets because I will be using one by one both the data sets. The data sets are somewhat different altogether. Uh, I will start with the YouTube survey data set. It is much more easier to comprehend. And I will go on to do Bargard's data set that is a little bit complex. So I can share with you that how to deal with a simple data set as well as how to deal with a complex data set. Both are real data sets. It is not simulated. Both are real data sets that I will work today with. And I've shared with you. Recording session is going on. I will try to do the hands-on session as slow as possible so that you can do along with me. But sometimes if I go fast, you just pardon me, then I will restrict my motion. And not only that, recording is going on. So at the end of the class or at the end of the course, at any time, I think if you wish to learn in much more depth, you can listen these or you can practice this hands-on several times. Only then you can do it on your own with your own data sets. Now, I will share my screen and just tell me that whether you can see my screen or not. I'm sharing the screen.
Hello, sir. I am Arpita. From which department you are, sir?
I'm from commerce and management department here at university.
Okay, sir. I am a scholar of this university also. So in future I can meet you. So that's why I am asking, sir.
Let
So
me
thank you,
start
sir.
the session. Then we can continue. Which
Hello,
department you are there?
sir. I am from Food and Nutrition Department, West Bengal State University. Thank you so much, sir.
Okay. Can you see my screen? Can you see the screen?
Yes, sir.
Yes, sir.
Yes, sir.
Can you read my writing?
Yes, sir. Cluster analysis.
Now, basically, this is a classification technique. Now, basically, you know the concepts of, I think, dependent variable and independent variable. You know the concepts.
Yes, sir.
So when we can identify dependent variable and independent variable, we actually call it supervised learning. And when we cannot identify this dependent variable and independent variable, then we call it unsupervised learning. Now, cluster analysis is a technique of unsupervised learning. Why? Because we cannot identify separately the dependent and the independent variable here. Now, since it is a hands-on course, so I will not go into detail about the theory. I will just touch upon a little bit of theory. I will much more focus on intuition rather than mathematics. Because if I start writing all the algorithms now, you will feel bored and you will not be able to capture the spirit of cluster analysis. So I will try to focus my presentation on maximum demonstration part with the help of SPSS. But to open discussion, we need to understand some concepts of cluster analysis so that we can proceed forward with the demonstration. And for that, I will start with a little bit of concept. Now, you know that we have certain respondents like R1, R2, say Rn. These are number of respondents. And we have, say, certain variables like V1, V2, dot, 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 Vp. Now you know that when we club the variables into factors, say third, 4th, 5th, F2, like this, we call it factor analysis. So factor analysis is a dimension reduction technique. Now, when the variables are clubbed into factors, why? Because there may be innumerous number of variables. It is not rational or logical to interpret those variables. So to reduce the dimension, we use factor analysis. Now, when we group respondents on the basis of characteristics or profile,
Sir, your voice is not coming.
you cannot hear me.
Sir, I am able to listen you correctly.
Then there may be some network issues from your side, because I am using the full volume here. Maybe due to network issues from your side, you are listening in a much low manner. All the participants, can you hear me?
Yes,
Yes,
sir.
sir.
Yes, sir.
Audible.
Sir.
Okay, okay. So when we are actually clubbing the respondents or the items on the basis of characteristics or features, we call it cluster analysis. So if you think of cluster and factor analysis, both are dimension reduction technique, because we are grouping the variables or grouping the items or respondents on the basis of certain algorithm, and we are reducing the data set. But the algorithm for cluster analysis,
So not audible now.
hello, you cannot hear me. I am using the full volume, I think.
No, sir, we can hear you.
Audio is not coming, sir.
ঠিকঠাক আমি তো ঠিকঠাক শুনতে পাচ্ছি অনির্বাণ দা।
Yes, sir. We also hear you.
I am using the full volume, 100% volume I am using, and my net is also stable now, so no issue from my end.
Okay, please sir, continue.
So what I was talking about is the algorithm of factor analysis and the algorithm of cluster analysis is different. Here, in case of cluster analysis, we will be using the distance matrix. In case of factor analysis, we use correlation matrix. So the matrix is different. So basically, on the basis of correlation between variables, we club those variables into factors, and concepts like eigenvalue come into the picture. Here, in case of cluster analysis, we will be using a different algorithm altogether, which is based on distance matrix. So this is the basic difference between factor analysis and cluster analysis, and the rationale behind doing factor analysis and cluster analysis I have tried to explain in simple language. Now, the algorithm is mathematical in nature, and if you follow any book, say Hare's book on multivariate data analysis, you will understand those algorithms. I will not focus on the algorithm today, because if I focus on the algorithm, if I focus on the mathematical equations, it will be not very much appreciative from your point. And since this is a hands-on workshop, so we should try to understand the practical applications and the intuitions behind this analysis. So I will go on to discuss some little bit about cluster analysis before going to the hands-on session. So till now, if you have any thing to ask, or if you fail to understand anything, you may ask me. I think I am audible.
Yes, sir. Audible now.
So I can proceed.
Yes,
Yes,
sir.
sir.
Now, there are different types of cluster analysis. Basically, there are three types of cluster analysis. One is hierarchical clustering. Technique. Second one is non-hierarchical clustering technique. And the third one is hybrid technique, which we call it as two-step cluster analysis. So this is hybrid, means this is a combination of hierarchical and non-hierarchical, which we call as two-step cluster analysis. The non-hierarchical clustering technique, popularly known as k-means clustering, and hierarchical. So one is hierarchical, second is non-hierarchical in the name of k-means, and third one is hybrid in the form of two-step cluster analysis. So three types of cluster analysis are there. So this is okay with you?
Yes, sir.
Now, can you see my screen?
Yeah.
Yes, sir.
Yes, sir.
Basically, what I was talking about is cluster analysis means grouping. Grouping of objects, maybe grouping of products or respondents on the basis of certain attributes. And the basic taxonomy behind cluster analysis is that the group should be homogeneous within and heterogeneous across groups. Means, suppose if there are three clusters or three groups, those three groups should be heterogeneous between each other, but the objects within each group should be homogeneous within each other. So there is a concept of homogeneity and heterogeneity. There should be heterogeneity across groups, and there should be homogeneity within groups. So I will show you how to prepare this diagram. SPSS will help you to draw this scatter plot. This is called scatter plot. And from the scatter plot, you can very well identify that how many clusters are here? 4 clusters. So from the scatter plot of cluster analysis, you will be able to identify that how many clusters are there in your data set. So this, can you identify how many clusters are here from the diagram itself?
Yes, sir.
4.
4.
Okay. Now, I was
4
talking about
clusters.
basically before clustering technique applied, the right hand side diagram is the before clustering technique applied. Just by the scatter plot, you can see that whether it is following normality or not, whether what is the correlation between the variables. But after applying cluster analysis technique, you will get the picture much more clarity. This is the left hand side diagram that already we have applied cluster analysis technique, and we have grouped all the data sets or the data points into different clusters. Now, I was talking about cluster analysis versus factor analysis. I have started with today with the discussion that classification technique, both cluster and factor is a classification technique. Rather, we call it as a dimension reduction technique in case of factor analysis, since we are reducing the variables into factors. And in cluster analysis, we call it as a classification technique. Why? Because we are classifying objects or for that matter, respondents into different groups. The basis of grouping is different. Both we are grouping, but in case of factor analysis, we are grouping the variables. In the case of cluster analysis, we are grouping the respondents or the objects on the basis of distance matrix, whereas in factor analysis, we are grouping the variables on the basis of correlation matrix. And the statistics that we will be aware of is dendrogram and different grouping techniques that we will discuss in case of cluster analysis. In case of factor analysis, you know that there are concept of eigenvalue, factor loading, etc. So the basic difference, there is also a basic difference between cluster analysis and discriminant analysis. Basically, when you are in a identify independent and dependent variable, we rather apply discriminant analysis technique, which is called a dependence technique. And when we are not in a position to identify dependent and independent variable, but we want to form association between the objects or respondents, which is called a interdependence technique, which is cluster analysis. Actually, we don't have any prior information before doing cluster analysis. But when we are trying to do discriminant analysis, we have a previous information beforehand regarding the objects and the features of those objects. So basically, today we will be focusing on cluster analysis, but I have tried to mention that there are close associations between cluster, factor, and discriminant analysis. And nowadays, application of cluster analysis is becoming popular day by day in different fields, in psychology, in biology, in understanding different climatic change or climatic conditions, environmental stream, we use cluster analysis. But the most important and frequently used technique of cluster analysis is in marketing research. So when we are trying to position the product in the market, when we are trying to segment the market, when we are trying to understand the buyer behavior or the consumer behavior, when we are trying to launch a product in the market on the basis of test marketing, we use cluster analysis technique. So cluster analysis is a much popular technique which is used in marketing research. Now, I was talking about that when you use a cluster analysis technique, you can think it as a process model. How? Because you have certain objects or things or respondents, you want to cluster them or group them on the basis of characteristics. And what do? You try to create a distance matrix. And on the basis of distance matrix, you try to form groups or clusters. So basically, how do we form clusters on the basis of distance matrix? And we have to identify important variables on the basis of which we will be grouping or we will do cluster analysis. So we have to use distance measure. That distance measure may be based on similarity or may be based on dissimilarity. Now, if you try to understand these two graphs, you will find, just from a layman's vision, you will find that both are same. Both looks like same. Can you tell me that whether there is any difference between these two graphs, which you can see in the screen? Can you find any difference? I think my screen is visible.
Yes, sir. The gap between the line 1 and line 2 is more or less graph 1 and graph 2.
See, if you see, initially you will find that hardly there is any difference. Only there is a difference between the distance between the two lines. Now, if you analyze here, if you try to understand the relationship between the two between the two lines in the two graphs, more or less they are same. They are r is equal to 1. So the correlation between them is equal, same, but the distance is different. Now, on the basis of factor analysis, on the basis of correlation matrix, we should have grouped it into a same bucket or same factor. But on the basis of distance matrix, they are different. So here, we will be applying cluster analysis on the basis of distance matrix. And distance between these two graphs is not equal. The two lines in the graphs are not equal. So that is our point of discussion today. We will try to use distance measures. There are different distance measures: Euclidean distance, squared Euclidean distance, Manhattan distance, Chebyshev distance, Manhalobis distance. All distances are there. I will not go into the formulas behind these distances, but rather you may note that out of all the distance measures, the most important and the most popular distance measured is the squared Euclidean distance that we will be using in our analysis of data sets today. And I have given you all these PPTs in your free time. You can go along with these PPTs. You can try to understand the basic concepts. I will not demonstrate this further because today my approach will be much on hands-on. So only those things which are very important, I will just touch upon those things in order to give a hands-on demonstration. So the first thing which is very important in cluster analysis is a dendrogram. When we will be using the SPSS, you will find that in output, one tree-like graph will come, which we call as dendrogram. Dendrogram actually helps us to identify the exact number of clusters, because when you have a real data set, say 1000 data set size. So if your sample size is 1000 and you are doing a cluster analysis, you are wanting to group them. So how to understand that what should be the exact number of clusters? So dendrogram will help us to understand, to make us understand that actually what should be the exact number of clusters. There are different validations techniques that we will discuss today in order to make it valid that what should be the exact number of clusters in any of the data sets that we are going to use. Now, another thing is very important, that is outliers. You know that when you are trying to screen the data set, you have to identify with the help of box plot that whether there is any outliers or not, because if there are outliers, then you have to remove those outliers in order to run cluster analysis. Because if there are outliers in your data sets and if you run cluster analysis, then the result will not be reliable. So we have to detect outliers on the basis of running box plots, and we have to remove those outliers before starting cluster analysis. Now, there is a concept of sample size, that what should be the sample size that we can run cluster analysis on. Basically, if you have say 300 to 400 data sets, hierarchical clustering analysis is okay. But if your data set is much more than that, say 1000 or 1200 or 1500 data set size, then you have to apply k-means, because hierarchical clustering technique will not be able to handle a large data set. And another thing is very important is that if the variables which you are using in your analysis are not measured in the same units, if it is measured in different units, then before doing cluster analysis, you have to standardize them. So you have to standardize the variables in same unit before running factor analysis. Otherwise, your rather cluster analysis, otherwise your cluster analysis result will be wavered. Now, I was talking about types of cluster analysis: hierarchical, non-hierarchical, and combination of both. Combination of both is the hybrid one, which we call as a two-step factor analysis. In case of non-hierarchical, the most important, or rather the synonym of non-hierarchical cluster analysis is the k-means cluster analysis technique that already we have discussed. So I have given you the entire PPT. At your convenient time, you can go with those PPTs. Only I have touched upon those concepts which is necessary for doing a hands-on session with you today. So as you can understand that since there are three types of cluster analysis, one is hierarchical clustering, second is k-means clustering, and third is two-step cluster analysis. So with the same data set, we will try to understand the three techniques one by one. So I will be starting with the YouTube survey data sets. Both are real data sets. I will do cluster analysis with both the data sets. First, we will start with YouTube survey data set. And I will request you all that those who want to do hands-on with me, please open the YouTube survey data set.
Yes, sir.
সরি স্যার, ডিস্টার্ব করছি। যদি কোনো এখানে ওয়েদারটা ঠিক নেই, তো আমি যদি কোনো কারণে লেফট আউট হয়ে যাই, তাহলে আপনি সেশনটা কন্টিনিউ করে ফিনিশ করে দেবেন স্যার।
Yes, yes, no issue. So the participants, dear participants, can you see my screen? This is a YouTube survey data set.
Yes, sir.
Yes, sir.
So those who want to do along with me, I have shared with you this data set. This is a real data set. And I will explain the data set first before going to run the cluster analysis. So if you check the size of the data set, see 1000 respondents are there in this data set. So this is a huge data set. This is a real data set. Now, what is this data set about? This data set is actually we have coded the data set on the basis of questionnaire, and the questionnaire was framed in order to understand the YouTube preference. The respondents, those who are using YouTube every day, what sort of videos they are watching, what is the frequency of watching these videos, what are the contents, what they like in those videos. So we have tried to capture those preferences, and we have used a demographic profile of the respondents as well. So we will try to group the respondents on the basis of the importance that they give while watching YouTube. So if you can see here, from 21 to 33, these are the variables that we have tried to capture, that why they are giving importance, why the respondents are giving importance to YouTube videos. So if you can see here, can you see my screen?
Yes, sir.
So if you check here, the first thing is who the content creator is, actually who is creating the YouTube video, that is important. What the video is about, what is the topic of the video, that is important. The quality of the video production, that is also very important. The quality of the audio in the video, that is also very important. Whether someone recommended the video or not, that is important. Whether you saw an ad about the video, that is important. How recently the video was released, how attractive the video thumbnail is, how accurately the title captures the actual content of the video, the colors used in the video thumbnail, how many views the video has, how many likes the video has, how long the video is, what is the duration of the video. So all these are the important characteristics on the basis of which the respondents have given answers, and on the basis of their responses, we will try to group the respondents into clusters. So this is okay?
Yes, sir.
So now let us start with cluster analysis. Go to analyze, go to classify. Now click hierarchical clustering. We will start with hierarchical, then we will go on to k-means, and then we will finish up with two-step cluster analysis. So let us start with hierarchical clustering. I think you can follow me.
Yes, sir.
Yes, sir.
Sir, can you
So
repeat?
just go to analyze, go to classify. Under classify, choose hierarchical clustering technique. Now choose all the importance variables. Bring it to the right hand side. Participant ID not required. So only the importance variables we have brought. Clear till now?
Yes, sir.
So under statistics, we will be using agglomeration schedule, and we will try to give a range of solutions. See, basically in social science data sets, basically the ideal clusters should be ranging between 2 to 5. And in case of huge data sets, there may be 10, 12 clusters. But generally in social science data sets, most probably the clusters should range between 2 and 5. We can validate that whether it is the right cluster or not. So no issue with that. So let us start with giving a range 2 to 4. So 2 is the minimum cluster and 4 is the maximum cluster we are starting with. So click continue. You can follow me. I am going as slow as possible. I think
Yes,
you can
sir.
follow. Okay. So click continue. So statistics over. Now come under plots. Now I have mentioned that dendrogram is the tree graph, which is very important in order to understand that what should be the exact number of clusters. Now, since I think you have clicked this dendrogram now, iCycle we don't need, only dendrogram will suffice for us. So click continue. Now statistics and plots over come under method. Now under clustering method, there are different methods between groups, within groups, nearest neighbor, furthest neighbor, centroid, median, words method. Basically in social science, we use most popularly centroid clustering and words method. Now, what is words method and what is centroid method? In a very simple language, centroid is the averaging clustering technique that you are trying to use. So actually, if you use centroid clustering, your groups or clusters may not be identical. Means, suppose you have 1000 respondents. So if you use centroid on the basis of the average distance from the mean or from the centroid, it may be so that there are different respondents grouped into different clusters. The size may be different. Means, say one cluster may have 600 respondents, another cluster may have 50 respondents. But if you use words method actually try to standardize the group's size. So basically, say in one group, if you apply words method, there may be 20 respondents. In another group, there may be 18 respondents. In another group, there may be 22 respondents. So more or less, the group size will be somewhat equal if we use words method. So today, I will be showing you both the words method and the centroid method with two different data sets in order to make you understand. So let us, since we have understood the data set here, that basically the YouTubers are giving preferences on their watching of YouTube videos. So more or less, the groups should be somewhat equal in size. Therefore, we should use words method here. So we are using words method. The interval, the distance measure is also of different types. I have already mentioned that the most popular and the most effective distance measured is the squared Euclidean distance. So we will keep it as squared Euclidean distance. And since the importance variables we have measured, the units are all same, so no need to standardize here. Otherwise, if the units of all the variables would have different, we need to standardize. But since here the data set, the variables are measured in same units, so no need to standardize here. So click continue. So till now you have followed.
Yes, sir.
Now,
Yes, sir.
this is by default display statistics and plots we need. Therefore, we will choose this. This will come by default. And you know that clustering is actually on the basis of cases. So we will choose cases. And the last button is the save. Now, since initially we are starting with, we don't know actually what should be the exact number of clusters. So we will not save the cluster membership now. Later, when we would have identified what should be the actual number of clusters, then we will save this cluster membership then. So initially we are starting with a trial and error method. So I'm not saving the membership. Now click OK. Now you can see here that there are 1000 participants. And if you see this agglomeration schedule, it is huge since the data set is very huge. So it is really difficult to read these huge tables and data sets. What we should do? See, we have given 3 clusters, means minimum 2 and maximum 4. So there are 3 clusters, 2, 3, and 4, and each respondents are being grouped into clusters. See, first respondent, if there are 4 clusters, would have been placed in 1. If there are 3 clusters, would have been placed in 1. If there are 2 clusters, would have been placed in 1. This is like we interpret. Now, the most important part I'm coming. Don't just worry by seeing this data set. I will make you understand. Now, this is the dendrogram, which will actually help us to understand that what should be the appropriate number of clusters. Now, we have given a range between 2 and 4, but what should be the exact appropriate number of clusters? We can read it with the help of dendrogram. But if you check here, since there is 1000 data set, see the dendrogram is somewhat unreadable. So what to do? How to make this dendrogram readable or visible? Just double click this. If you double click this dendrogram, automatically this chart editor will show. And now if you right click on this chart, I think you can see my screen. You can
Yes,
see.
sir.
So if you right click on the chart editor, you will find this properties window. If you click the properties window, I think this is visible. Now click the chart size. Under chart size, don't click this maintain aspect ratio. Make it neutral. Maintain aspect ratio, make it unclicked. And just change the height to, say, 8 inches. If you change the height to 8 inches and if you unclick the maintain aspect ratio, now if you click apply, if you close it, let me do it again. Bring it to 8. Okay, just 8 inches. then it will be much more shorter. If you resize it as far it is permissible, automatically you will be able to read. So let us reduce halfway.
Sir, read the
Now, can you see my screen?
Yes, sir.
Yes, sir.
Can you reduce which I am showing you? On your screen, you can reduce it. So let me run the dendrogram. Actually, some problem is there. Let me again run the dendrogram. Okay. So if you see the dendrogram here, if you check it, see here, basically, this is the one, this is the second. So if we can draw a line here, if we suppose this is the dotted line, I can see, you can see this. If this is the dotted line drawn, then basically we will say that there are two clusters here, 1 and 2. Similarly, if we shift the dotted line to the left, again we can say that basically 1 and 2 is the cluster. Similarly, again if we shift the dotted line here, it is unchanged, 2 cluster. Now if we further shift this dotted line here, extreme left, now you can see that how many clusters will be there? 1, 2, 3, 4, and 5. So if you move the line from right to left, the number of clusters will be more. Now, how to understand actually what should be the exact number of clusters? How to understand this? Now, in order to understand this, what we have to do is we have to, I will show you that if you just check this cluster centers here from the agglomeration schedule, if you double click this agglomeration schedule and if you highlight these coefficients, now just you have to highlight this coefficient. Okay, so if you highlight this coefficient, now this is the coefficient. So if we highlight this, and now when you have highlighted this coefficient, if you click right click, if you do and come to create graph, and if you click a line graph, see here, see here the line graph has come. So basically, if you check the line graph here, this is a reverse scree plot, and the reverse scree plot, basically the rule is that it should be like elbow. So you have to check that whether there is elbow or not, where is the bend. So if you check here the bend, you can very well identify that the bend is somewhat here. The bend is somewhat here. So you can very well identify that this is the first one, this is the second one, this is the third one, this is the fourth one. So like this, it is being parallel to x-axis. So from this you can have an idea that whether it should be a 3 cluster or a 4 cluster, or it should be a 5 cluster. Now, another thing that we can very well do with the help of this clustering, hierarchical clustering technique, is that we if we save the, say, cluster membership, and then we can actually validate also. So now again, if you go to analyze, if you go to classify, if you go to hierarchical clustering technique, and here under methods, it's okay. Under plots, now when you have understood that what should be the exact number of clusters, maybe 3, maybe 4, so you can now use this single solution. And in single solution, you may just now give, say for example, we have understood that it may be between 3 and 4, so we are trying to check as 4 should be the exact number of clusters. So now when you have found it, now go to save and now give cluster membership as 4 and click continue. So if you now click OK, if you go to the data set now, check here, see the cluster membership has been given. So first respondent is coming under cluster 1, second respondent coming under cluster 2, third respondent coming under cluster 1, fourth respondent again coming under cluster 1, fifth respondent coming under cluster 3. Like this, all the respondents, the 1000 respondents are being clustered into 4 clusters. So this is how we do it. Now, in order to make this simple to read, what you can do is you can go to data and pick sort cases. We have this cluster membership column added here. Otherwise, you can, what you can do is if you click here, if you right click and click sort ascending, then it will be easier for you to interpret. Now, see, first respondent coming under cluster 1. Similarly, see here, 168 coming under cluster 2. Likewise, you can make it much more readable, that which one is coming under which cluster membership. So this is how we actually try to do cluster analysis. We try to understand that what should be the exact number of clusters and which respondent should be within which group or which cluster. Okay. So hierarchical clustering is clear to you?
Yes, sir. But one question is there.
Yes.
Sir, is there any plotting just you have shown before?
Which one?
there was one slide in your PPT that which is showing some clusters are there, and around these clusters you have made some circles.
That is actually a scatter plot.
Okay.
We can actually do that scatter plot only if we apply the two-step cluster analysis. I will come. Okay. When we will be doing the two-step cluster analysis, automatically the scatter plot will be generated. Okay.
Okay, sir.
Basically, I want to tell you that initially I have mentioned that if your data set is too large, here you can see that we have a real data set comprises of 1000 sample size. So generally, plain speaking, if your data sets range between 300, 400, till 400, it is better to run this hierarchical clustering technique. Otherwise, if your data set is large, say this like 1000 or 1500 data set, it is better to run k-means. Why? Because k-means will give you a much more accurate result. I will show you the k-means now. Since our data set is huge, 1000, so we can better interpret and validate using k-means clustering technique. Okay. So till now, if you have any doubt, please ask me. If you have any doubt till now, you may ask me, or otherwise we will go for the non-hierarchical, that is the k-means clustering now. So if you have any doubt till now, you may ask me.
No, sir.
So we can now proceed towards k-means clustering.
Yes, sir.
So now go again to analyze. Come to classify. Under classify, now choose k-means clustering. And we have to choose the importance variables. So before that, before starting, since we have already created, we have not saved. Okay. We have not saved the previous cluster membership, because if we have saved, we have to delete that. So go to analyze, since we are starting afresh. Go to classify, go to k-means clustering. Now that same variables are important, that is importance variables. So we choose this one by one. And bring it under variable box. So till now you can follow me.
Yes, sir.
Yes, sir.
Okay. Now click iterate. Since k-means clustering is a iteration technique, so it will iterate in order to converge it to 0. So convergence criteria is 0. Now, sometimes there may be more iterations. So it is safe to increase this 10 by default to 99. Because it will converge to 0 on the basis of the algorithm. So it may take 6 iteration, it may take 10 iteration, it may take 14 iteration, it may take 25 iteration. So just to make us safe, we increase 10 to 99 because for certain data sets, it may not converge to 0 within 10. So it is better to increase it to 99. So click continue. Now, under save, you need to check cluster membership and distance from cluster center, but I will not check now because I don't know actually what should be the exact number of clusters. So I'm not saving it now. Later we will save. Go to options. Under options, apart from initial cluster centers, we need to check the ANOVA table because ANOVA table will help us that whether the groups or clusters which should be framed is fair enough or not. So ANOVA table will help us to identify the exact number of clusters. So we choose ANOVA table. Click continue. Now here, since K means K is the number which we know. So initially we will start with say 4. Then we can come to 3, 2 to 5 you can check. It will be a trial and error method. I will show you how to check. And it will give you the exact result, what should be the exact number of clusters. So initially we start with 4. This is I'm hypothetically I'm taking 4. I will change it to 3, 2, 5 in order to make you understand that what should be the exact number of clusters. So let us start with 4. Now click OK. Now here, if you check the iteration history, it is very important. See how much after 34 iterations, it has been converged to 0. So if by default we would have taken 10 iterations, it would have not have converged to 0. That's why I was telling you that you should keep it 99 because we don't know that how much time it will take to converge to 0 while iterating. So here from this, you can see that in 33, all are not 0, but in 34, all the clusters have converged to 0. This is clear to you?
Yes, sir.
Now, if you see the ANOVA table here, you know the significance value. That is, if it is significant, it should be less than 0.05. You know that? You know that? The significance value? You know how to interpret p-value, that is the significance column? No or don't know, tell me.
Yes, sir.
Yes, sir.
So basically, if you check here, the ANOVA tables tell us that which variable out of this are significant. So rather, we can run it again. Okay, iterate 99, options, ANOVA table, we have clicked, number of clusters 4. So now check. Actually, ID has come into our analysis. So I have removed that ID. Only the importance variable you should check. Now this is the final one. This is the correct one. Now if you check here, the iteration history, it has converged. All the clusters have converged to 0 at 16 iterations. Now, if you check the ANOVA table here, see all the variables, the F size is not equal. You know that if the F size or the F value is more, means that variable is more important. But here, if you check all the variables, if you check the significance value, all are less than 0.05, means all are significant. Means the clustering which has been done on the basis of these variables, all the variables have played important role in the clustering technique. And if you check from here, out of 4 clusters, 325 respondents are in the 4th cluster, 223 respondents are in the 3rd cluster, 185 respondents are in the 2nd cluster, and 267 respondents are in the 1st cluster. So out of 1000 respondents, all the respondents have been given cluster membership. And see here, all the variables are important in order to frame the cluster. So we can check from the ANOVA table that whether our cluster is good or not. So we can, from here, we can see that the 4 clusters are good enough. Now, on a trial and error basis, we will try to check that whether 2 cluster or 3 cluster or 5 cluster is much better than the 4th cluster we have chosen. So again, we go to analyze, we go to classify, we go to k-means. Now, keeping all things same, we will change the number of clusters to, say, let us start with 5. We have already done 4. We will check 3 and 2. So we have given 5. All things remain same. Click OK. Now, if you check the iteration history here, at 21 iterations, it has come to 0. And if you check the ANOVA table, see, all the variables are still much important. All are significant. So 5 clustered is also a good one. And on the basis of 5 clusters, you can check that 232 fall in 1st cluster, 78 respondents fall in cluster 2, 250 fall in cluster 3, 166 fall in cluster 4, and 274 fall in cluster 5. So we can see here that it is fair enough. Now, to make it much more practicable, what you can do is you can click this final cluster center, and you can, what you can do is you can select this one, all these things, right click, go to cell properties, and under cell properties, you can increase the decimal point to 2. If you do it, now you check that you can very well compare the average value of the who the content creator is. Suppose this is the variable. The average value is 1.57 in case of cluster 1, 4.21 in case of cluster 2, 3.18 in case of cluster 3, 2.40 in case of cluster 4, 3.83 in case of cluster 5. So if you compare these 5 clusters, you will tell that who the content creator is. That is very important for 2nd cluster. Means those who fall in 2nd class, 78 members or 78 respondents have given much more importance to who the content creator is while forming the cluster than cluster 3 or cluster 5 or cluster 4 or cluster 1. Like this, we can interpret one by one all the variables, and we can check that which variable is important, most important for which cluster respondents. This is how we can do it. Now again, So 5 is also good, 4 is also good from our result. So you can very well choose between 5 and 4. And generally what happens is, if you have this final cluster center, and if you can, what you can do is you can select it and you can create a graph as well. So if you create a, say, bar graph, see, you can check here that more or less all the clusters are different. If you check the orange one, importance matrix, how many views the video has, here for cluster 1, it is between 1 and 2. For cluster 2, it is above 4. For cluster 3, it is near to 3. For cluster 4, it is between, again, 1 and 2. For cluster 5, it is somewhat more than cluster 4. So all are different, somewhat different. So we can say that basically all these variables are important enough. From the significance value also we can say that all the variables are important enough in order to create cluster membership. So I think it is clear to you now that k-means is much more useful if you have a larger data set while doing cluster analysis. Clear?
Yes, sir.
So have you followed all this? If you have any doubt at any particular part, you may ask me, I can repeat it again. So everybody have followed? Any doubt? You may ask me. Please give some answer, otherwise I can't understand whether you are getting my point or not.
No, yes, sir. We are getting your point.
Yes, sir. Clear.
Okay. So it is a, please unmute and ask me. No issue if you unmute yourself. I don't mind, because it is really tough to see the message box. So Saurav Barbora has asked, is it possible to take more than 99 iterations? You can take, no issue, because the SPSS will by default converge to 0 on the exact number of iterations. So it may take 10, it may take 14, it may take 25, it may take, but 99 is much more. It is very well understood that SPSS will not take so much iterations to converge to 0. So 99 is a safe number.
Sir, let me ask you one thing. What if the data set is larger than 1,000 readings, like maybe 10,000 or something like that?
Yes, you can. This is a machine learning decade. So you can very well handle with k-means. Okay.
Yeah.
No
Okay,
issue.
thank you. Yeah.
So any further doubt you can ask me, or otherwise we will proceed to the two-step cluster analysis technique now.
We can proceed, sir.
Okay. So on the same data set, now come to analyze, come to classify, and choose two-step cluster analysis technique. Analyze, classify, two-step cluster analysis technique. So you can see my screen.
Yes, sir.
Acha. Before starting two-step cluster analysis, one thing we have to check that whether we have saved cluster membership or not. We have not saved, so no issue. So now go to analyze, go to classify, click two-step cluster analysis. Now we will choose the importance variables that we have done. So click the importance variable, select those. Bring it under continuous variable because all the variables are continuous in nature. We are not using any categorical variable here. If we have used categorical variable, then we would have brought under categorical variable. So basically, what is the difference between two-step and say k-means or hierarchical clustering technique? Just to recap once more, if you don't know what should be the exact number of clusters, and if your data size is say less than 400, you start with hierarchical clustering, and through dendrogram you will be able to identify what should be the exact number of clusters. Now, if you have a larger data set, say 700, 800, 1000, 1500, 2000 data set, so then what you do is you do a k-means clustering technique. Now, the assumption is that your variables should be continuous in nature. You know that measurement scale talks about four things. One is nominal, ordinal, interval, and ratio scale. So interval and ratio scale are the continuous variable, and nominal or ordinal is the categorical variable. So if you have any variable which is important, which is categorical, so bring it under categorical variable, and those which are continuous, which is measured in ratio or interval, bring it under continuous variable. So all our variables are continuous in nature. That's why we are bringing it under continuous variable. Now, under options, this is by default. We don't need to change anything under options. Under output, you can check this create cluster membership variable, because two-step cluster analysis automatically will generate the exact number of clusters. So that is why it is so much important. It is a hybrid in nature. It will create the cluster membership by default with its algorithm. Now, we have chosen this create cluster membership. Click continue. Here, these two are important. So number of clusters, SPSS can automatically determine it if you allow it to determine. Maximum by default it is taking 15, but it will generate you the exact number of clusters. It may be 4, it may be 5, it may be 3, it may be 2, it may be 7. It will generate automatically. And if you are very confident that you want to specify it, so if you want to specify the number of clusters, then I will tell you that the distance measure you should choose is Euclidean distance. And you can specify the exact number of clusters if you know, say 4 or 3 from your previous knowledge. Now, if you don't have the previous knowledge, so better to let SPSS determine the exact number of clusters, and then the distance measured should be log likelihood, and the clustering criteria should be AIC. And we should try to minimize the AIC. If it is minimized, then we can say that it is the exact number of clusters. So we are choosing archaic information criteria under clustering criteria. We are choosing distance measure log likelihood when we are allowing SPSS to determine the exact number of clusters. If we would have confident enough, if we would have specified the fixed number of clusters, then we should have chosen Euclidean distance. So since we are letting SPSS to determine, now you click OK. Now, see here. If you check here, how many number of clusters it has assigned? 2. And if you check the cluster quality here, this silhouette measure of cohesion and separation. Cohesion and separation means heterogeneous, cohesion means homogeneous. So what I was mentioning, that your clusters should be heterogeneous from each other and homogeneous within each other. On the basis of that criteria, that is the silhouette measure, see the quality is coming under fair. So this yellow color is fair, green is good, red is poor. If it comes under red, you cannot proceed with cluster analysis, you can interpret, because otherwise it will be rejected. Your paper and your analysis will be rejected. You may carry on if it comes under yellow, and it will be much good if it comes under green, but since you are using a real data set, so it is really little chance to be under this good. So it is fair and we can proceed with that, no issue. Now, another checking here is that on the basis of the variables, you can see that 35.8% is in cluster 2, that is 358 respondents are in cluster 2, and 642 respondents are in cluster 1, it is 64.2%. And the cross check is here. If your ratio of sizes, it should be less than 2. If it is less than 2, means it is perfect clustering. Since it is 1.79, which is less than 2 here, you can very well be assured that here the 2 cluster is appropriate cluster. Now, if you come to these clusters, automatically you can check here that which variables are important in forming these clusters by just checking the mean size, 1.51, here 1.41, here 1.41, 1.99. But if you come here, see, check the importance. What is the importance here? 0.10. Here importance is 1. Here importance is 0.89. So gradually it is coming lower. So the importance is lowering when you coming below. If you check the color also, you can identify these are much more strong colors, highlighted colors. These are fade colors. So it means that which are strong colors, highlighted colors, means these variables are important in clustering. These variables are not so important in comparing to the other variables. Now, another thing that we can check here is, if you come here, the cluster sizes, and if you check the predictor importance, here again it will show you. See, if you check all the variables here, all these variables, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 variables we have. If you check the importance, see how many views the video has is the most important variable, followed by the colors used in the video thumbnail, followed by how many likes the video has. So all these are much more important variables, and gradually the importance is being lowered. So this is clear to you?
Yes, sir.
Now we can do a cluster comparison as well. How we can do the cluster comparison? See here. This is a box plot, you know, and this is the median value. If you check here how many videos the video has, the median is 3.01. For cluster 1, the median is 1.01. So for cluster 2, this variable is much important than cluster 1. Similarly, if you check the second variable, median size 3 for cluster 2, median size 1.01 for cluster 1. So this is how we interpret that which variable is much important for which cluster on the basis of the median value. And you can very well tell that which variable is giving more important to which cluster. And if you check this one, you can see both the medians are same. Both the median are same. So here this variable is not important for both the clusters. This is how we interpret. And this is so much important in order to analyze. What you can do is you have to interpret this table in your research analysis. So how you can bring it in your Word file? You can go to edit. You can choose copy auxiliary view. If you choose copy auxiliary view, then what will happen? I am showing you the Word file now. Rather, I open a new Word file. I think you can see my screen. My screen is visible. So
Yes, sir.
if you open a new Word file, now let us paste this. You can make it big as well. So this is how we bring it, and you can interpret below. Each variable one by one you can interpret. Clear? Clear how to bring the analysis?
Yes, sir.
So if you have any doubt regarding this two-step cluster, you may ask me. One was asking me regarding the scatter plot. I don't remember his name. Can you again just unmute and tell me regarding the scatter plot that you were asking?
Yes, sir. I was asking
Yes.
about the scatter plot.
So what we can do is here, if you go to graphs, if you click chart builder, I think my screen is visible.
Yes, sir.
Yes, sir.
So you need to check here the scatter dot. Okay. Scatter dot, say we are choosing this second one. So now what we are trying to do, we are trying to bring this participant under set color. Say we have importance variables. Say suppose I'm bringing one variable here. and another variable, say bringing it here. So this variable is who the content creator is, and the second variable is the quality of the video production. Now we can change the color as well. So so can you see this chart?
Yes, sir.
Yes, sir.
So this is actually this scatter plot. Now only you can create scatter plot by choosing two variables at a time, not more than two. Why? Because in any scatter plot, there is y-axis and there is x-axis. So suppose you have 10 variables or 12 variables or 13 variables, but only you can create scatter plot by choosing two variables at a time. This is clear?
Yes, sir.
So if you go to graphs and you use chart builder, if you use scatter dot, you can create scatter plot. Okay.
Okay.
So any doubt till now, you are free to ask me. So you can unmute and you can ask me, you can interact